Hello, I am Engineer Hamza. Today I will be walking you through the fascinating world of railway engineering. If you're a curious mind, a student or a professional, then you need to know how railway engineering shapes the world around us. In this series, we'll explore the basics of railway engineering, its vital importance in modern transportation, and the rich history that brought us here. You'll discover the main components of railway systems, different types of railways, and the science behind their design and construction. We'll also dive into career opportunities in this dynamic field, and by the end, you'll understand how railways operate safely and efficiently every day. Whether you are a civil engineering student, a transportation enthusiast, a railway professional, or simply curious about how rail systems work, this series is designed for you. Welcome to railway engineering. Railway engineering is a branch of engineering that deals with the planning, design, construction, operation, maintenance and safety of railway systems. It combines several fields including civil engineering, mechanical engineering, electrical engineering, transportation engineering, and even computer engineering. Railway engineering ensures that trains move safely, efficiently, economically, and comfortably. Without railway engineers, there would be no rail tracks, no train stations, no signalling systems, and no organised train movement. Rail transport is one of the most important transportation systems in the world. Why? Because railways can move large numbers of people, heavy goods, industrial materials and agricultural products over long distances efficiently. Compared to road transportation, railways are more energy efficient, more environmentally friendly, safer for mass transportation, and better for reducing traffic congestion. Countries with advanced railway systems often experience stronger economies, faster movement of goods, better urban transportation, and industrial growth. That is why many countries, including Nigeria, are investing heavily in railway infrastructure. The history of rail transport dates back to the early 19th century. The earliest trains were powered by steam engines. These steam locomotives revolutionized transportation and industrial development. Over time, railway technology evolved into diesel trains, electric trains, high-speed rail systems, and even magnetic levitation trains, known as maglev trains. Today, countries like China, Japan, France, and Germany have some of the most advanced railway systems in the world. In Africa, railway modernization is also growing rapidly. Nigeria has seen major railway developments such as the Abuja-Kaduna Railway, Lagos Rail mass transit projects, and ongoing national railway expansion programs. All right, Section 4. Main components of a railway system. So, a railway system consists of several important components. Let us look at the major ones together. First, we have the railway track. The railway track is basically the path on which trains move. It consists of rails, sleepers, ballast, fasteners, and formation layers. The track must be strong enough to withstand heavy train loads continuously. Next is the rolling stock. Rolling stock refers to the vehicles that move on the railway. Examples include locomotives, passenger coaches, freight wagons, and metro trains. Then we have railway stations. Stations are locations where passengers or goods are loaded and unloaded. A well-designed station improves passenger comfort, safety, traffic flow, and operational efficiency. Now, let's talk about the signalling system. Railway signalling controls train movement, and its main purpose is safety. Signalling systems help prevent train collisions, overspeeding, and operational confusion. These days, modern railways now use computerized signalling systems. Finally, there's the power supply system. Electric trains require electrical power systems such as overhead lines, substations, and traction power systems. Section 5. Types of railways. So, railway systems can be classified into different categories. First, we have passenger railways, which are used mainly for transporting people. Examples of these are metro systems, intercity trains, and high-speed rail. Next up are freight railways. These are used for transporting goods and industrial materials. These trains carry things like cement, fuel, containers, agricultural products, and heavy equipment. Urban rail transit is another type. These operate within cities. Examples include light rail, metro rail, and tram systems. And lastly, high-speed rail. These are advanced railway systems operating at very high speeds. Some even exceed 300 kilometers per hour. Countries like Japan and China, are global leaders in high-speed rail technology. Railway engineering offers, so many career opportunities. A railway engineer can work in areas like railway design, construction, maintenance, transportation planning, railway operations, signalling, track engineering, safety management, as well as research and academics. With the increasing railway investment all across Africa, the demand for railway professionals is growing really rapidly. This field has opportunities in government agencies, construction companies, railway corporations, consulting firms, universities, and even international transportation projects. In this course series, we'll cover topics such as railway track engineering, rails and sleepers, ballast design, railway curves, super elevation, railway signalling, railway construction, high-speed rail systems, railway safety, and modern railway technology. We'll also solve engineering calculations and practical examples step by step. For example, in future lessons, we'll study railway curve design using equations like E equals GV squared divided by 127R. This is where engineers calculate the required super elevation needed for safe train movement on curves. Railway engineering is more than just trains and tracks. It is the engineering system that connects cities, powers economies, supports industries, and shapes modern transportation. As railway technology continues to evolve, the role of railway engineers becomes even more important. This is just the beginning of our railway engineering journey. In the next lecture, we'll discuss the history and development of railways in Nigeria. If you enjoyed this lecture, please like the video, subscribe to the channel, and turn on notifications so you do not miss upcoming lectures in this railway engineering series. Also, drop your questions in the comment section. Welcome to the world of railway engineering.